Hi, good morning, everyone. How are you guys? Were you able to do some revision in last 1, 2 weeks? I mean, since you got a good break, I hope you all like kind of made the best out of it. So what did you guys do in last 1, 2 weeks? And specifically, like what all issues are there? I mean, in terms of end-to-end projects. End-to-end project is something that we will anyhow cover, but what all other things do you want me to cover in these two sessions today and tomorrow? Mm, Credit card, default payment, and others. Okay. So I shared some projects also with all of you. I mean, this is over and above the work that we have done, right? I mean, some of the projects might be overlapping, some might not be. So there are beginner level projects, right? And then there are some advanced level projects also, right? So those who have not even started anything, right? I think for them this could be one starting point, right? And those who have already covered it, I mean, they can still move with the intermediate part. See, grid search, may you will, it's not like you just use an algorithm. Using an algorithm is not the trick. Feature engineering is the trick. You have to spend time with your data. You have to keep on doing more and more EDA to find out what new features can you build. You have to remove the features. You have to add the features, right? So don't think so that, okay, baseline, and after doing hyperparameter tuning, you will get. No, it's a good data set to work on. This is the Kaggle one or some other one? Oh. You can actually see what other people have done, okay, and try to learn from there. So there will be notebooks which people have published. Try going through like 5, 6 or them, see their approach, and then try to experiment with them. Okay. I mean, there are some basic things, standardization and all that you can still follow, right? But what is specific to the problem that you have to see. I mean, you have to understand the data a lot, understand the business scenario a lot. For example, for credit card problem, what is the one key thing that you know, do you think can impact anyone who is doing payment? This is the data set with the UCI credit card data set, which has 30K rows. Is that what you're working on? So TSNE is a dimension reduction technique. Okay, so what we do with TSNE is let's say we have hundreds of dimensions, right? What we do is we reduce the dimension to visualize it better. Okay. TSNE, PCA, all these are dimension reduction techniques. So for example, let's say I gave you, again, let's say you're using this credit card data set, right? You have, in this we have around features. We have around 25 features. Okay. Now, if you have to visualize each of these 25 features, it's difficult, right? So what I do is instead of 25 dimension, I compress the information of 25 dimension in just 2 dimensions. So that's nothing but a dimension reduction technique. TSNE is more related with visualization, right? And PCA is yeah, PCA is also dimension reduction technique. TSNE is more for visualization, and PCA people use for actually reducing the dimension and apply algorithm on it. So basically, like from 25 dimension, you can go to 4 or 5 dimension, and then uh, apply your machine learning models on it, right? With TSNE, it's more about visualizing the data. PCA will reduce precision and recall in a lot of cases where you have already less number of columns, right? So it's not like because when you're doing PCA, you are actually losing some information, although you are reducing the dimension, but there is a information loss. So PCA also should not be applied blindly. Okay. PCA should be applied with some, so there is something called how much variance does the PCA explain? So that factors needs to be kept in mind when you are doing PCA. Okay. So uh, that's something related to how much of the data you want. Okay. I think these were the few topics which were still left. PCA dimension reduction is completely left in our last module, uh, which was I think after we covered some of the deep learning part. But yeah, that's and retraining of model is nothing but, so let's say maybe you have created this credit card default model. Okay. So you created a model, that model is getting used as of now. Okay. And what used, when I say used, what I mean is in the production environment, it is getting used. Okay. So now you created a model with today's data. Okay. Now, after a year, I mean, there will be new trends, right, in the data. So you need to retrain your model after every, you know, quarter, 6 months, or a year. It could be different with different use cases. Okay. Any other thing that you guys have? I mean, better to actually go through questions rather than going through anything else. So now what we will do is I'll tell you how you can actually make a project with any data set. Okay. Big, small, whatever. Right. So let's try to do that. Okay. So that you guys can also pick any of the data set that you want to do. What is the difference between boosting techniques, boosting and bagging, or different boosting techniques? So there are in typical there are boosting, bagging, and stacking. Okay, you know the difference between all. In all the boosting techniques, you will still use voting and combine models of same type, right? The main difference between boosting and bagging is that uh, in bagging, each model is built separately. In boosting, each model has an influence on the other model. Okay. So that's why there is a different weightage to each of the individual model. Okay. So in boosting, there are EDA boost, gradient boost, XG boost, right? And if you go through the slides that we have, we cover all the differences also. Okay. So like with gradient and XGBoost specifically, since you are asking, both of them are using gradient descent to optimize. The only difference is XGBoost supports regularization also. Okay. So gradient boosting and XGBoost is something like gradient boosting is given by sklearn and XGBoost is a separate thing altogether, right? So both of them uses gradient descent algorithm to converge, right? But um, XGBoost is much more powerful because it has some more advantages, like regularization is one of the biggest one. So uh, try to revise the things, right? If you haven't done already. Okay. And if you want to go into mathematics of it, like difference between gradient and XGBoost. So if you can just look at their loss function, the loss function will be a bit different. But in both, the common factor is the gradient descent algorithm comes into place, which is used to minimize the loss function. So what I will do is I've divided into this particular thing into two parts. Okay. So I picked one of the projects which I listed from an intermediate category because I mean, this is a huge data set. So if you see, we have around 234,000 data points. So good, decent data set rather than working on small data set. I thought we should work on some bigger data sets. Uh, let's try to understand the problem. Yes. Okay. So this is a Black Friday sales prediction problem. Let me share it with everyone. Let's firstly understand the problem statement. Okay, so there is a retail company, any retail company, who wants to understand the customer purchase behavior against various products of different categories. So they have shared purchase summary of various customers for selecting high volume products from last month. The data set also contains customer demographics and everything and total purchase amount for last. Now they want to build a model to predict the purchase amount of customer against various products, which will help them to create personalized offer for customers against different product. Okay, so I have also not attempted this problem, so I'll be doing it along with you. And the reason for choosing for such problem is so you will know the way I approach it, right? And in this approach, we'll also try to cover uh, basics of Python. Okay, like today we'll be going through a lot of how we can use slicing and all, right? So right from slicing to advanced thing like group bys and some descriptive stats, merging and joining, reshaping, stacking, unstacking. So we'll look at all of it. Okay. And then we look into EDA and then finally model building. Okay. Now, 2 days are not enough to work on any problem. Okay. The next thing you need to do is invest more time in it. Okay. In understanding the data. Any good project, okay, that you have to do will involve you at least spending 30 to 40 hours in it. Okay. So if you think you can do a project in 3 hours, then so everyone could do it, right? I could have just copy someone else code and just do. So the problem statement here is there is a retail company who wants to understand the customer purchase behavior. Okay. So let's say this is something like maybe something like Amazon. Okay. So what they have is they have shared as a purchase summary of their high volume products. Basically, let's say whatever is the Amazon bestseller, let's say. Okay. And it also has customer demographics like what's my gender and everything, right? And also the product which they bought. Okay. And total purchase amount from last month. Okay. Now, what we want to do is we want to predict how much will the customer purchase in this month. Okay. What type of problem it is? Is it regression or classification? Regression, right? So that's something that you need to know. Second is you should know your evaluation metrics. So your model will be evaluated on the basis of the prediction of the purchase amount for this. And we at our end will this fine. So at the end they will compute RMSE, right? With which we have to compete. Okay. Any doubts in understanding the problem statement? Is everyone clear with the problem statement? Yes, no. Awesome. So there are two ways to work on it. One is obviously you can download the data, right? Uh, the other thing is that what you can do is just use Kaggle, okay? And on Kaggle, since already GPUs and everything are available, CPUs are available, so it's easy to scale out there. Okay, so it's up to you where you want to do. Okay, so let me just go back out here. Yeah. So what you can do here is just click on new notebook. Let me firstly share this link with you also. You can click new notebook and just start using this only. So Black Friday analytics Vidya solution one. Okay. I mean, you can have your own naming conventions. Uh, One of the main and easiest reason for using Kaggle is you already have the dataset loaded, so things become a bit easy. Okay. Alternatively, what you can all do is you can actually just sign up for this competition and we'll be submitting our solutions here only. Okay. And then you can just download it in your local and use it. Okay. So up to you guys how you want to do. So just go quickly and download the dataset. What do you guys prefer to use? Local or Kaggle or whatever? Just use any, I mean. Kaggle it becomes easier, so up to you guys. Just checking the data set. In my sample submission file, I'm just checking how the submission file should look. So purchase, user ID and product ID. Okay, this is my sample submission file. So basically with each user ID, each product ID, how much is going to purchase. So that's something which we have to predict. Has everyone loaded the data? Let's quickly just read in the data. Yeah, yeah. To download, you will have to register or download it from Kaggle. Na? Kaggle, I gave you the link. I use either of them, Kaggle or that. Kaggle is a way you can download the data. 550,000 data points and 12 columns. So I have these 12 fields. So one is the user ID, production ID, sex of the user, age and men's, occupation, categories of cities. Okay, stay in current city in the city, how much time he is staying. Fine. Now this is a bit different from the other problem that you might have done till now. In all those problems, what we were doing is we were doing a prediction only on one ID. Here, it's combination of user ID and product ID. So basically, let's say can spend more on electronics, but I can spend less on maybe fashion items. Uh, yeah, yeah, it has 5.5 lakhs only. Acha, let me also check. 5500. That's 5.5 lakh only. In test, it is 250. Okay, so first thing is obviously checking the shape of the data frame, right? And if we have to check few rows, we use head. Okay. So what from the head we can see is user ID, product ID. Okay, these are some IDs. Gender is male, female. Age is age category rather than age. Okay. Occupation, we have to see what are these categories. Okay. But there are some occupational categories which is given. So it's written occupation has been masked. So when we say masked, it means there is some occupation, but they have masked that particular value to something. They don't want to reveal it. Okay, so many times clients will mask the values. Okay, so for example, let's say I am working as a data scientist, you are working as a software engineer. So what they will do is for every data scientist, they will give some X label, maybe some number. So maybe data scientist is 2 and software engineer is 3. So every scientist is represented by the number 2, something like that. Okay. Yeah. The masked and encoded is a bit different. Mask is you cannot see the value. Encoded is you cannot decode. I mean, you are actually encrypting and decrypting it, right? Okay. So the next thing that we should do is just quickly look at the summary of the data. Right. Describe. So here you will get to know what is the counts. As you can see, this count is different thing across these two. So there are some nans and product category 2 and 3, which we can see up front out here. And if we just try to understand this also, this is product category again must. Product may belong to other category. So basically there is some product which can belong to multiple categories also. So it's like that. And the purchase amount. If we see the purchase amount, it is from minimum of this $12 to a maximum of $2,391. So we might have some correlation, okay, between product categories and amount, because there will be always some product categories that are cheap, right? And then there will always be some product categories that are expensive, right? So let's quickly see what all things we have. So looks like these are non-null. Only these two are the values which are null. Okay. The other way to check null is, are you guys doing along with me or not? So I hope everyone is doing. I can go slow. So as you can see, like product category 2 and product category 3, I mean, you can directly see you have null values. So null values can be checked using is null function, right? Then there is a function called is NA to check NA values. Okay. So if I have to check is NA, yes. Always check for both is null, is NA, right? If you have to check for a specific column, so you can also do this. Let's say I want to check for this particular column. I can just write not NA, I'll get these flags, which all of them are not NA. If you use any, then you're checking all the rows. So basically, what happens is the null is an absence of value. Like, NA is basically used to detect something like not NaN. Okay, not a number. Okay. So it depends. Sometimes it will be shown as null, sometimes it will be catched in NA, right? It depends how that particular CSV is saved. But essentially both are representing the same thing. At one place you are just checking it's not a number. Okay. So NaN, right? In other place it's an absence of value, right? So there will be a highly overlap between the two. How can we fill the missing values? What all techniques do we need? Do we know? So mean mode, okay. Then there is something called backfill, forward fill. Can we? So what? Let's do this. Let's do some Python revision. Okay. And what I'll do is I'll create a copy of the data frame so that I don't change the original data frame. So I have created one more data frame, df1, df.copy. Okay. So let's try this. Let's try to fill blank values, right? With some padding. Okay. So use the fill NA method and try using different methods in that. One is pad, one is backfill, one is forward fill, right? Can you all try that? And then check if we have still have missing values. So we are doing some quick revision of Python values. Okay. I mean Python functions. That's why I've created a separate data frame because I don't want to disturb my original as of now. What is the function that we use? We fill. Has everyone tried it? Okay. So there are different methods. Like one is simple fill NA. Okay. Here you can write different methods, right? So if you can just scroll this documentation, you will get to know backfill, bfill, pad, ffill. Okay. So this is one way to fill anything, right? And you can actually see what pad and ffill is using is propagate last valid observation forward to next. Bfill may next valid observation. So basically one is filling from back, one is filling from forward. Shift tab. So I can use this, right? And if I just don't want to assign it again, what can I do? I can use in place is equal to true, right? So once I do that, let me again check if I don't have, if I still have missing values because it's a fill, right? So you can see even though it has filled, but one value is still left because I mean, it's again padding from forward values, right? Because pad and ffill both use forward, bfill or backfill both uses backward. Okay, so maybe I should have filled it with bfill. So I'll just change it to bfill. Okay. Now also I have a lot of, no, wait, df1 is equal to this. Yeah, I'm still having some missing values, right? Which I need to see. So based on this, you can choose either this, either that, or even you can do it on your own also. So you can choose which category you want to impute it. Okay, so let's change it back to our pad. Okay. Have you heard of something called an assert statement? So let's do this. Since we have done padding, we have one missing values. And if we just quickly check, where is that one missing value? It is at the very start. So let's use, after using this, let's again use backfill so that we don't have any missing values. So bfill. Now I should not have any missing values, right? So let's say I want to check that none of the columns should have uh, missing values. So I can use something called an assert statement. So assert statement checks for a condition that should be true. So for example, if I'm writing assert 1 is equal to 1, okay, so it will just execute because this condition is true, so it won't give any error. However, if I'm just giving assert 1 is equal to 2, which is a false thing, right? So it will give me an assertion error. I mean, it won't execute. It will give me an error. So if and whenever you are checking in, let's say whenever you are doing this in program in production environment, when I say production in actual customer employment, right? So let's say you are filling a website form, right? Which website पे forms fill करता है, right? Many a times you click on submit, but it doesn't get submit because it requires certain values, right? Or maybe it checks for format of certain values, right? That has happened with everyone, right? So we can use assert statement out there. Okay. So now what I want you to do is use this assert statement to check if we have any null values, okay, in my data frame, which is df1. You have to use assert statement. And just to give you a hint, there is one more method to check null values, which is not pd dot not null. I mean, which you already know, like not na, we have not null. So if I'm just giving this, it gives me something like that. Okay. So you can use some extension, which will give me at column level. And if I just do it again, it will give me an overall value. So maybe you can use this as a hint. Okay. Can you try? Did you guys try using assert statement? तो simple है देखो. You have to check for null values and just do it at overall level. There are multiple ways of it. So see, one way is I check for null values, take a sum at column level and then at row level. So what you could have done is this. This is one way out. Another way out is pd dot is null pf1 all all not null. I have to check for the opposite thing. It's not. This is again one way to use assert statement to check we don't have null values. So just use any of these. Okay. So as of now, what we are doing is we are trying to play with the data, trying to understand the data. Okay. So what's better than using indexing or slicing the data, right? So what all methods do we have for indexing and slicing in pandas? Log, ilog, and ix. Okay, so log is label based, ilog is integer based, ix is both, or ix or I mean now ilog also does it, right? Both label and integer based. We can actually slice the data frame. Okay, so let's try to look at the 10th row. Can everyone do it using just log? And when you are doing it, provide me the code also. So one is I want the 10th row. Second is I want first 4 columns, or maybe first 4 rows of age and occupation. The next thing I want is first uh, uh, last 2 rows of first 2 columns. Can everyone do this? These 3 things which I've asked. And it's a Python revision, guys. We haven't started with the machine learning. So Python refresher. Okay. Can everyone do it quickly? And lastly, what I want is reverse the whole data frame. When I say reverse, what you need to do is last column should come first and last row should come first. We have to reverse the whole data frame column wise as well as row wise. Let's do some Python practice and just change the data frame name. Okay, I mean we are already using df1, so it's fine because we are just experimenting. Quickly do this. Okay. What about others? Simple 10th row, first four rows of is, last two rows of this, reversing the whole data frame. तो सिंपल पाइथन है इसमें कुछ भी मशीन लर्निंग करने नहीं है ये जस्ट रिवाइजिंग सम थिंग्स इन पाइथन व्हिच आर इम्पोर्टेंट So for reversing, Sahil, this will reverse only the rows. So once I do this, it is just reversing the rows. I wanted to reverse rows as well as columns, which is, so if I have to reverse columns, it's nothing but this. So if I do both, then I have reversed the columns as well as rows. So this is the thing that you need to do. Okay. Now let's do this. Get me the index. Get the index of the row with maximum purchase value. This is purchase, maximum purchase. Similarly, maximum and then minimum. These are the next two things that I want you to do. So use ilog wherever there is a number and use log wherever there is a column. So first four rows of age and occupation. So I will use log out here. First four rows. That means colon 4, age and occupation. So age, right? First four rows. Last two rows of first two columns. So wherever there is a count, a number associated, I can use ilog. So last two rows, how can you get last two rows? Of first two columns. So first two columns is this, right? Just have to reverse everything because so what last two rows of first two columns. So first two columns we have selected. We just need last two rows. So it will be like this. So minus two, basically second last, to end. So that's why minus two colon. Then colon to two means first two. Any doubts, anyone in this? So getting 10th rows was easy, right? I mean, let me just do it here only. Strength, DF1. Okay, there are multiple ways. I mean, you can use log, ilog, or whatever, right? So I can just use 10 and just this. Okay, I'll get the 10th row. Now, first four rows of age and occupation can be done using this. Okay. Last two rows of first two columns. So in this, what you had to do was last two rows, so -2. Okay, टू एंड, ठीक है, तो -2 कॉलन आ जाएगा जिससे तुम्हें लास्ट टू रोज मिल जाएंगे। फर्स्ट टू कॉलम्स के लिए कॉलम से लेके सेकंड तक, तो जस्ट माइनस इज फ्रॉम लास्ट एंड प्लस इज फ्रॉम स्टार्ट, राइट? These three things will basically, these are the three answers. Okay. The next thing I want you to do is get the index of the row with maximum purchase and get the index of the row with minimum purchase. Okay, so yes, ID max and ID min. Now let's go one more step ahead. I hope everyone knows this. Okay, this will give you uh, the IDs of the max and the min, right? Let me just print it out. Now there is a function, there's an operator called at that can be used at and I at. Okay, that can be used to access single value for a row. For example, I want to access this maximum value now. Okay, so now I know. Okay, so I can use dot 80, whatever index I got, comma. Okay, so this was probably the max value. So let me also just check it using describe 2391239. So at is used to point to one particular value. Okay, so here you cannot do something like, this. So it's different from like lock and ilog. It's just to specifically point at one value. You could have used lock also out there, right? So it's the same thing, just to get particular value. Similarly to at, we have something called I at. Okay, that is similar to ilock. So what you can use is IAT, this row, and maybe let's say this is second. Was I audible? I just saw my mic was on mute. Oh, my mic was on mute. Okay, so what I was saying is ID max, ID min. Okay, you can use at and I at. Okay, to extract the values also whenever there are single values. Now, why knowing this at and I at is important? Because at times you will be given MCQs and you might think, okay, at is not an operator at all. So you should know. Okay. So let's do this now. So all of you are aware about booleans, right? In Python. So let's look at some booleans out here. Okay. So what I want you to do is using log, check for a user ID. So what I want you to do is get the purchase amount of user ID this and the ID this. And next thing that I want you get the purchase amount of user ID which is having user ID this or this. And the last thing that I want is user ID should be this and product ID should not be this. quickly. Okay, so this is exactly what it is, right? I think I got on mute again. Yeah, it can be done using if, but this is the most easy and sought out way to use. And here the trick is if you don't use these brackets, it will not work. Okay. So let's use some advanced concept now. So there is something called where method. Okay. Let's try to use that. So have you heard about where method? It's very same as ours using block, right? So all we need to do is df1 dot where, right? Inside this, you give the condition. So maybe this could be one condition. So same thing. Okay. If you see, this is not getting, everything is coming as then, and I have all the rows. So all this where condition does is it will give you true or false, nothing else. Wherever there is, fine. There is not, it will give it as any. So then you can actually think of dropping them or whatever, right? I mean, if I have to get exactly something, so I might use something like this, and that's a where of, right? But if you have to check any condition, use where. You can check for multiple conditions also. I mean, the same condition. Again, wherever is not applied, NN will come in all the rows. Now you can apply it on a particular column, you can apply it on anywhere. Okay. Have you used something called query? So to give you one example, let's say I want to query my data set. This SQL में query होती है, right? Not exactly like that, but somewhat similar to that. Okay. I want to query, right? And I want to query in maybe, let's say product category 1 is greater than product category 2 because all these are numbers. So product category 1 is greater than product category 2. Okay. So this I have to do, and I'll provide all this in my codes. So all the data where product category 1 was greater than product category 2. You can just use this rather than using apply and then checking each and every values. Okay. So can you check this? I want to check if product category 1 is greater than product category 2 plus product category 3. Can you all do that? Just use this query keyword. This is should be greater than 2 plus 3. You're not getting any result. Mm. Just check the columns that you have in your DF1 because I'm getting it. So you should also get. Just check once your data types. You might have messed up with some of the data types. So in my case, both of them are float. So just check once. And also check if there are no null values. I have handled null values also. Okay. It's as simple as that. And you can check for multiple things. I mean, you can check for mm, gender. This you won't be able to check because of, yeah. So anything that you want to do, you can do it within this query. And this is faster. That's one of the biggest advantages of using this. It's faster also. Okay. Was everyone able to try this and get this at least? How you can use this? Yes, no. What about others? Okay. So let's now shift to our categorical variables and try some operations out there. Okay. So give me the value counts, okay, of gender in an ascending fashion. Okay. So I want how many male and females are there, but in an ascending fashion. So gender distribution. And same cheese in percentage. I think this should be fine. So query, why are you using query? I needed value counts in an ascending order. I mean, simple, right? All you need to do was print TF1, gender, gender is G capital, value counts. Inside this, there is an option. If you just click Shift Tab, so there's something called ascending. By default, it's false. All you need to do is ascending is equal to true. You'll get it. So female and then male. Similarly, if you have to do percentage wise, here you will write normalize is equal to true. You will get percentage wise. So 24% are females and 75% are males. Okay. So these are some important things about data frame. So axis, D types, empty, number of dimensions, size, values, head, tail, this you all know, right? So just keep all this list handy whenever you are working with a data frame. Okay, this helps. Similarly, things, some other simple for operations like T, transpose. So if we would have done simply like this, rows ko columns and columns ko rows, it's as simple as just using this, right? It's a big operation and big data sets. It will take some time. So I'll just cancel it out. Dot axis. So if you do, it will give me what is my rows. So it starts from zero, end with this, and what are my columns. D types returns the data types. Empty, okay, returns if the if some data frame is entirely empty, no items. So obviously this will give us false, right? Because none of the data frame is completely empty. So this can be used. Ndim, number of axes or dimensions. And this is also easy to use. Two dimensions, one is rows, one is columns. Shape, size, values, right? So if you see values, so same data frame, but in a NumPy representation. Okay, so basically an array of list. So you can use that. Head and tail you already know. Now there are some more functions which come handy like these. So count, sum, mean, median, mode, standard deviation, min, max, absolute value, prod is product of values, cum sum, cumulative sum. This is used a lot of times and asked a lot of times. You guys also had in one of your, I think, test. So whenever you are checking index, ID max, ID value, right? And similarly these. Okay. Now let's look at some statistical things. Can you all give me the correlation metrics? Or let's take a break. Let's take a break of 10-15 minutes and be back by 11:10. Okay. Yeah. Now tell me in this correlation, what is the most correlation? Okay. So let's come back in 10-15 minutes. By 11:10, let's be back. Okay. And then we can check. Okay. In the meantime, whosoever is staying, I want you to rank the data frame and get me the top 25 rows. So I want the average rank in the group. Basically, you want to rank each and everything. Okay. So when I'm saying rank, I want to rank each and every column. Let's be back by 11:10 and then we'll continue. Whoever is there, please give me the answer of this one. So what does this, I hope everyone is back. So what does this rank do? Is everyone back? Hmm. It will just rank it by that and assign one category to it. Group by we know, right? So can you just group by maybe by city and just extract by city and then just extract one group, maybe the group A. I just want you to group and then just get all the data of this particular group A. The next thing I want is, I'll just check. So, so by taking get data of these two things. Yeah. So I've all collated all these basics in one Kaggle notebook out here. You can do a upvote once you do that. Okay. So whenever you have time, go through this particular notebook, whatever we have covered today, and even some more functions are out here on the same Black Friday data set. Okay. So that way you can actually at least try it out. Now, tomorrow what we'll do is we'll try to solve this problem. I mean, till now we were actually doing a revision of Python, that what all can be done. Now you have all the tools, right? You know how to do things, whatever data munging, right? Now the next thing that we have to do is do a prediction on the same, right? So let's do some EDA, okay, on our original data frame. Just mention out here what all I am looking for that you need to do now. Now this is something list that I am providing, but you guys need to create it for yourself when you are doing it. So a few questions that you can have is get unique values for each column to understand the data. Second is when you're doing analysis, just do a univariate analysis. Okay. So in univariate analysis, what you can look for is maybe purchase distribution. Okay. Using plots. Okay. Then by gender, by city, by age, occupation. So give me plots for each. Okay. This way you will understand what is the data like. Marital status. We don't have marital status, sorry. We have no? Marital status. Occupation is we have already covered. Okay. Product category 1, 2, 3. So all these you can just writing like this. Okay. So univariate analysis of all this. Now the second thing that you should look at is a bivariate analysis. Now all this when you're doing it, don't just do it because I'm asking you. I want conclusions out of it. Okay. So let's say one of the simplest conclusion could be um, which gender buys the most, which cities has the most purchasing power, which city has the minimum purchasing power, and try to classify the customers accordingly. For example, now I could be from a city like Delhi versus a person from a city like Kanpur or maybe Lucknow or whatever, right? I will have different purchasing patterns. Okay. What are the common products purchased by a person in one city? Things like that. Try to answer these questions using this. Okay. Obviously, I'll show you what I did, but I want you to spend some time today and then I'll walk you through what other steps I followed. Okay. The next thing that you can look is at bivariate analysis. So you can use something like called pivot tables. or cross tab to do this. You can check for things like maybe gender and purchase pattern. Are some particular gender more able to purchase, like females purchase more or not, right? Similarly, you can look at purchase with age. Similarly, you can look at city and purchase to understand the data. Occupation and age and purchase. Again, marital status and purchase. Here you need to answer few questions like, okay, average price per product category is also something you can tell. Which is the product category which is most expensive and least expensive? Are you guys with me? When I'm listing these things down, this is something you guys also have to do when you are starting on a project, right? No one will spoon feed these things to you, right? So create such list like I am doing right now in front of you because uh, I mean, this is something which we have to create by ourselves, right? Till now, we haven't even got into machine learning because we are trying to just understand the data. Okay. We just looked at few things, few function as a revision on what all we can do. Now it's more about, okay, what we should look for, right? And finally, when all this is done, we have some understanding, we will go to our data pre-processing, basically preparing the data for training ML models. In fact, before this also will come with a baseline approach. A baseline approach could be as simple as average price or maybe average price per category, per product category. I mean, you can try with anything. Then we'll do some data pre-processing. We'll try to understand the data, right? And create a model. Okay. Then we try to see which variables are important. So this is called feature engineering. So you have a one baseline ML model. Then we try to see feature importance, which features are important to us. Okay. Using different models. So you can try decision tree, random forest, right? And others. So this is the whole plan that we will try to execute. Okay. So I want you to start with this. Okay. And then tomorrow I'll walk you through the implementation I have done, and you walk me through the implementation you have done and tell me the insights. And then let's discuss it to wrap it up. Okay. By the end of tomorrow session, you already will have some baseline. I mean, you already will have a model and a project to report in your resumes, right? Because this is a good data set to work on. So start with this. Start with the first point. I'm typing it here. So please copy it. Okay, is it fine with everyone? Yes, no. Hmm. I want you to practice so that tomorrow in our final session for this, we can close out. Okay, I don't want to spoon feed. Okay, then you won't be able to take any project. This is the list of steps that I have created. I want you to check this and create your own list of steps. I mean, basic, you all know. These are the basic steps. Okay. Now you can, one of you can add grid search in this. Someone of you can add some other step in it. How to create features is another step, right? So now, I mean, just let's try to understand this once more. Okay. So this is my data set. Let me just do a head again. I have gender, age, occupation, city, stay in current years. Okay. Marital status and all these and purchase. Okay. So do you think when you're creating model, user ID and product ID play any kind of a role in determining the purchase amount? Because this will be every time it will be a unique combination, right? So product ID might or might not, but if there are 3,000 different products, you cannot determine it, right? Because you have to, and the end result that you want to do is how much this user will spend on this product, not like how much this product cost for. अगर वो होता तो I can look at just the product catalog, right? Why do I need to loop in user, right? So for example, I know iPhone X, let's say cost 50,000 rupees. ठीक है? That तो I already know ना. I want to see how much, let's say the iPhone X is 50,000 rupees. Me as a user, how much I can spend on that iPhone. Maybe I can just spend 20,000. So the way company will approach me is give me EMI option. Okay. And let's say you are a person who can actually spend 70,000 on the same phone. So for you, it will give me, it will give you basically a recommendation that if you buy the phone and pay and all, you'll get some discount, maybe something like that. No, no, no. See, these user IDs will be same, right? But these are not helping you determine the purchase, na? Right? It is not helping you determine. IDs will rarely help you do any kind of prediction. It is required only as a field which should be there just so that you can track. For example, index, rows, columns, it's like that. Okay. How will we know that this person has spent more? More than what? Okay. So it's only for tracking. Okay. Nothing else. Because in your test data, you'll have different users for different products. You won't have the same thing, right? So if you remember when we looked at this, so these are entirely different users. So you have to see the impact of this on purchase, not the impact of this. You're not doing a prediction for the same people, right? You're doing the prediction for the new people. For old, so you already know. It's not a time series problem, right? In time series, you need to track, okay, today I am spending 10 rupees. Tomorrow, how much I will spend. Okay, that's a time series thing that you will see. But here, so I'm just looking at different people and different products. So I'm focused on these things, right? So that's why understanding problem statement is necessary. So IDs will never play a role in 99% of the cases. In fact, 99.9% of the cases. Okay. We have to get to know what role gender, age, occupation, city plays. And I mean, along with others. Now, do you think staying in one city will have any pattern with purchase? These are the questions that you have to ask from the data. No, no. Amit, what was the problem statement? Did I ever mention how much male or female will purchase? I'm saying how much these factors contribute in together, right? So let's say you have a new user. Tomorrow you are a new user. There's a new user who comes in. Okay, let's say he is a male. His age is 40. Is working in this particular occupation, stays in this city, and you have all these values. Now you have to tell me how much that person will purchase. That's the prediction that you want to do, right? Like you signed up for Amazon. Now do you want to assign how much you will buy? Okay. For us, we want to see, okay, how these factors are contributing. Okay. So if I know, maybe it could be only gender which is impacting purchase. Maybe it's mix of gender age. I don't know. That's why I'm applying those machine learning algorithms to understand that particular behavior, right? You need to ask these questions like, okay, which gender is gender having any impact? Is age having? That's why I've done those univariate analysis. That is actually doing this. Then this bivariate analysis is actually capturing these parts where, okay, these are the people that might have some impact out here, right? Right. Is marital status having any impact on purchase? Is occupation having any impact on purchase? Is city and purchase, right? So bivariate we are already doing. Using all this, you will come with a baseline approach. Maybe your baseline approach is कि अगर वो फीमेल है और इस सिटी से है तो वो इतना स्पेंड करती होगी. So maybe it could be as simple as that, right? And then we feed it to machine learning model and try to see. Okay. Now, one more thing that you have to think of is, can you include some feature or can you reduce the feature? So reducing features, I already talked about dropping these IDs. Okay. Now, can you add something, right? That you have to see. Since this data is already categorized in a very good way, so we might not. Okay. But we have to see whether it makes sense or not. Okay. Similarly, the way I have chosen product category one, basically I've filled missing values that might have an impact. Maybe I should not even choose that particular thing, right? Or maybe I use a mix of all the categories. Again, that's some decision that we have to take. Okay. So start on that and tell me, start now, right now, and before tomorrow's class, please wrap this. Then only we can do a successful end-to-end project, right? Play with the data, play with the data, answer questions from the data, ask your data कि ये हो सकता है क्या? मतलब it's as simple as you being very much inquisitive about your data. You have to be curious. Okay. Okay. So let's start with this right away. So let's do this with Chaitanya. Tomorrow, you give me the approach that you have followed. Okay. And then I'll tell you what you should do to fix that approach or change that approach. Okay. So explain the problem statement to me. Okay. What you understood with the problem statement, what all features you have in the data, and how have you approached it. And then I'll can comment on the approach. Okay. Is that fine? Because that way you also get to know that whatever you were thinking, is that into correct thing or not. Just list your approach. I mean, it's not that difficult.